Good afternoon, everybody. Welcome to the session today. I'm really glad that everyone is here. Hopefully, everyone has been enjoying Google Next. Can I get a pulse? Is everyone enjoying Google Next? Awesome, great. So my name's Amrita. I'm a product manager on the Google Compute Engine. I'm joined here today with Simon. And together, we're going to go through all the content and demos that we have planned today. So let's get started. So before we go in, let's kind of see what we're going to talk about for the next 15 minutes or so. The first is I'm going to talk a little bit about why you should bring your Windows Server workloads to Google Cloud. We're going to talk about some of the features on the platform that customers really love and choose Google GCP for it. Then we're going to go through two customer journeys that we see most commonly. We have customers faced with the problem of, hey, I have all this legacy applications, and I really need to move off my private data center into a cloud with minimal refactoring in a very time-bound fashion. So we're going to talk a little bit about all the support that we have on the platform for that. And then there's a second customer journey that is very common, which is around, hey, I want to move to the cloud, but I want to actually make sure that the legacy applications or the applications I have actually use cloud services, kind of have auto-scaling, reliability without me having to write any code. And we're going to go and take a look at what support we have for that journey. And Simon is then going to help actually put all those tools that I talk about to use and demo how we can take an application and move it in these two different fashions. In the end, we're going to have Q&A, and Simon and I will also stay back. So if there's content that you did not see or have a lot of questions, feel free to reach out to us. So let's get started. Why bring your workloads to GCP? Specifically for Windows Server, we've been investing a lot in Windows Server all the way since 2015. That's when we launched our very first Windows Server image. Since then, there have been a lot of improvements, specifically for Windows and SQL Server. We have a wide variety of images to choose from, both for Windows and SQL, different versions, different editions. We've also built a lot of features that are required for enterprise-ready workloads. So enterprises want support for clustering. They want support for high availability. They want the methods that work on-premise to also work on cloud, and we now have support for that. From the developer side, if you are a .NET developer on Google Cloud, we've also built in a bunch of tooling for Visual Studios, PowerShell, and StackDriver for ASP.NET logging and monitoring. In the last 9 months, based on the customer feedback, we've been focusing on two major areas: migration and security. For migration, I'll go into a little bit detail as to what support we have. And in terms of security, two things that we've worked on is private IP support. We heard loud and clear that you want to make sure that there's only private IPs on your Windows VMs and your SQL VMs, and that's in preview now, going up public very soon. So we're also going to be very excited to announce some features around secure boot, which apply to both Windows and SQL Server VMs. Now, that session on shielded VMs, this is the product, is tomorrow. So please stay tuned for announcements around that in the keynote, as well as a deep dive session at 11 o'clock. So I'm going to go into 3 reasons as to why customers, specifically for Windows, love bringing their workloads to GCP. The first one is performance. When you bring your applications, whether it's Windows, SQL Server, or .NET, you're actually running on the same infrastructure that Google runs on. Your traffic never leaves the Google Fiber, even when you're going across data centers. But what does that mean for you? That basically means that you get super fast latencies, consistent throughput. You get all the improvements that we put into performance to make sure that VMs boot up fast. You can have a large number of VMs boot up, so customers don't need to keep these pools of warm VMs ready. And you actually get the best of our Google network for you. So things like, we've had a lot of tests around how our network compares to the others, how some of our products like GCS, which is Google Cloud Storage, and Google Compute Engine compare. So there is a site called cloudbenchmark.com where we've published some of these test results, and I highly encourage you to kind of go and take a look at that. The second is price. Our philosophy has always been to keep pricing simple, flexible, and try to offer you the best price. We have products like sustained use discount, where we monitor your workload. If you're running at steady state, we automatically give you a discount. We have things like right-sizing recommendations that are constantly monitoring your workload and making sure we give you recommendations that will save you and recommend the right configuration. We have features like per-second billing, if that is something that you can use to kind of get the maximum out of making sure that your VMs, you pay for the VMs only up till they are used. One feature I'd really like to talk about, especially with Windows and SQL Server, when you're running licensed software on VMs, these licenses charge on a per vCPU. So when you have features like custom VMs and extended memory, you can actually get a lot of cost savings. So a lot of customers, especially when they're running SQL Server, they want to go for the N1-16. And the first bar over there shows you what the estimated cost of running Windows with the licenses is for a month for N1-16. But let's say you're running that not because you need 16 vCPUs, but you really need that 104 gigabytes of memory because your workload is memory intensive. You can actually get that using custom VMs and extended VMs on a VM which has lower vCPUs. So if you want to work with an 8-core, 10-core, 12-core VM and not a 16-core VM, you can actually size that. And that makes a huge difference in the price that you pay for licensing as well as the base VM. The next reason that a lot of customers really like is security. So at Google, we have this policy is we trust nothing. We build a lot of purpose-built hardware to make sure that we have the full history of the stack that we run on. Titan is an example. It is a custom security chip that provides root of trust on every GCP device. Our investments in making sure that we detect vulnerabilities early and make sure that we patch our host systems without any performance or downtime for our customers. And Project Zero, which is the Spectre or Meltdown vulnerabilities, is a great example of that. Specifically for Windows, I'd like to repeat that we've heard that customers really want private IP support for Windows VMs, and that's available today. If you click on that link or come to me later, you can sign up and you'll have that available for your projects soon. We also have some really fun announcements, which unfortunately I can't disclose, but do attend the session tomorrow at 11:40 to learn about Secure Boot and a bunch of other features for Windows VMs. Lastly, reliability. And I mentioned reliability because as we're patching hosts or as we are doing our maintenance to make sure you have the most secure platform, we can do that without having to reboot your machines or give you any application downtime. And this is possible because we have technologies like live migration. So these are some of the reasons where customers like to come to the Google Cloud Platform. They get the best performance for the best price. They're guaranteed that the systems are secure and reliable. And overall, you have a great experience running your workloads on our platform. So now let's take our second part, right? Let's talk about a customer journey. So a lot of our customers have been running their data centers for many years. They have a lot of legacy applications. And they now want to move to the cloud, right? They don't want to refactor because they have thousands and thousands of applications, and they want to move as is with minimal refactoring in a very short time period. So the question is, for customers with such Windows and SQL Server workloads, what support do we have on the platform for them? So let's look at a little bit at that. One question I get asked a lot, and therefore I like to address this up front, is what flavors of Windows do you support? You support the latest flavors, but we do understand that some customers need to have their own time frame to how they upgrade. So we also have support for legacy OSs. So with the latest and the greatest, which is 1709 and 1803 images, we also have, via our migration tooling, support for legacy OSs like 2003 and 2008 R1. When customers want to migrate, they like to know, OK, great, the platform supports this version. How do I actually migrate? And over the last few months, we've been working a lot on our migration story, giving you different options based on your scenarios. There are 3 options that I would like to go through today. One is the virtual disk import. The second one is our VM migration capabilities through Velostrada. And the third one is Cloud Endure. Now, the first one is really good if you have a few golden images or a few golden disks, and that's the way you want to spin up your infrastructure on-premise. and use the same image to spin up your infrastructure on the cloud. We recently announced our acquisition of Velostrata, and that adds a really rich set of capabilities to orchestrate mass migrations. Last but not the least, we have a great partnership with Cloud Endure and have helped move many customers over using their SaaS-based VM migration tooling. So let's dig into this a little bit more. So what is the virtual disk import? A lot of customers have what you call golden images or golden disks. Now, this is your software, your scripts, and everything pulled into one that is certified by your IT or security admins. And this is what is your source of truth for spinning up infrastructure on premise. And you probably want to use that same on cloud when you spin up infrastructure there. So we have a really simple command line tool, which you can download. And with a few simple commands, you can actually convert that disk into an image in Google Cloud. And just like you spin up infrastructure using our images, you can use this custom image to spin up infrastructure. The same way as you can import, you can also export from GCE using the same command line tool. Next, I'd like to talk a little bit about Velostrata. As I mentioned, Velostrata has an enterprise-grade migration tooling, and we're very, very happy that they are now a part of Google, and all these capabilities are now available to our customers within the platform. What is unique about the Velostrata offering is they have a unique streaming technology. Now, what this does is it streams the virtual machine on demand, and you can actually have that VM booted in Google Cloud without having all the disks moved over. Now, in most migration technologies, you actually have a full copy of the entire VM state, all the disks attached to it, and then you're able to boot it. What this really gives you is the flexibility of having that VM boot up in minutes, verify that your applications look good, and then give a thumbs up and continue that migration story, or thumbs down, reboot, start again. You can also do things like right-size your VMs, add different policies and checks, and then kind of continue your migration journey. So it gives you a lot of flexibility. The second thing to note about Velostrata is it integrates really well with VMware, so vSphere and vCenter APIs. They've done a great job in making sure that that works really well. So if you have Windows Server workloads or SQL Server workloads running on VMware, this provides you a seamless way to kind of move your workloads from your VMware workloads on-premise to GCP. We've had a lot of sessions that probably talk about this, and I'm happy to go into more details. Let's talk about our third solution. So we've been working with Cloud Endure for over 18 months. They're a great partner and have helped multiple enterprise customers move. This is a great solution if you're working in a multi-cloud environment. So Cloud Endure solution is really good in moving from any source to GCP. We have the way they migrate is through block-level replication, and they have support for all flavors of Windows as well as Linux. So you have three different options based on your requirements, based on your workloads, based on your timeline. You can move and pick and choose and move your workloads to GCP. We also understand that in migrations, you probably need more support than just information about tooling. So we have an organization, which is the professional services organization. And this organization has worked with many of our enterprise customers to assess their enterprise environment, understand the needs of it, do a POC, and then figure out what is the best strategy to migrate to Google Cloud. So if you go to cloud.google.com/solution/migration center, you'll have a lot more information about the different plans available. Great. So we talked a little bit about Windows servers. We talked about the migration tooling. Now let's talk about your backend. So a lot of the Windows .NET applications that we have SQL Server as a backend. So customers ask me, what are the images you support? Just like Windows, we try to support all flavors and versions of SQL Server. And you also have to support for two ways to license it. You can use our images, and you can pay as you use. Or you could actually have your SQL Server licenses brought in if you have software assurance, and that gives you an ability to bring over your licenses through license mobility. When we think about SQL Server migrations, customers have different paths. Some of our customers use the migration tooling that we just spoke about, and some of our customers have different approaches to do that. So I'd like to talk about 3 approaches. So the first one is a lot of customers just spin up SQL Server VMs on GCE, and then they do a restore and backup of their data from on-premise onto Google Cloud. The second option is we went through a bunch of our migration tooling, and if you have, specifically, if you're trying to bring your own copy of SQL Server with the license included, a lot of our customers use some of the migration tooling that we just showcased. And the last one is lock shipping. So a lot of customers try to do an availability group. They have a DR SQL Server on Google Cloud, and they try to use replication or lock shipping natively supported technologies in SQL Server to cut over. So now that you've actually cut over and landed your SQL Server VM on GCE, you have your application stack, how do you ensure that you get some of the enterprise-grade features? So we have support for the 2 major recommendations from Microsoft for having highly available SQL servers on-premise. So the first one is availability groups. So you're probably familiar with always-on availability groups. And we have support for that. It gives you like a regionally highly available configuration. You can keep your SQL nodes in 2 different zones in the same region, or you can have them cross-region. The good thing about this is it's a multi-site failover cluster solution, and you really don't need a load balancer for it. So if you look at the documentation that we have, with just some simple networking rules and routing, you can actually have this set up really quickly. We have a simple click-to-deploy template. So if you go to our cloud marketplace and search for SQL Server always-on availability groups, you will see a template, and with one click, you can actually deploy this and test it out. The second option we see, and this is typically for SQL Server VMs that are running before 2012. So a lot of customers have physical SANs. They have their databases connected to that. A lot of customers who have queries which are cross-database still want to have this configuration for SQL Server HA. And the way to kind of support that is we are now figuring out how we can build a virtual SAN on Google Cloud and then have both your primary and secondary nodes connect to it. So the way we have enabled this technology is by using Storage Space Direct, which is a feature supported in Windows Server 2016. What this feature allows you to do is it allows you to cluster all the disks attached to the various nodes that you have provisioned in a Windows cluster and present that as a single volume to both the nodes on the system. So this is really cool. It actually gives you a virtual SAN at a very low cost. It replicates your data across these disks, giving you a pretty highly reliable solution. So we have support for that. We have detailed documentations, and just like the first use case, we have a one-click deployment template for that too. The third option is we've worked with SIOS, who's a partner, and they have a solution called Data Keeper. And this is very similar to the SQL Server FCI solution, where you can actually have SQL Server clustering without the need for a SAN. So they also have a virtual SAN technology. The difference between SQL Server FCI that I showed a slide before and this is you can actually use this for versions of Windows Server before 2016. So if you have some compatibility reasons where you want to have Windows Server 2012 and still want this feature, this is an option. It's also a really cost-effective option because it works with SQL Server Standard. So if you have SQL Server Standard and you still want to have HA, this is one way in which you can support it. Cool. So just to recap, we talked about how you can migrate stuff to Google Cloud. We talked a little bit about SQL Server and the different HA technologies that are supported on GCE. Last but not the least, people want to know about identity. And there are 3 ways in which we actually support different Active Directory use cases. The first one is customers have their users and groups defined on their on-premise Active Directory domain controller. And they just want to sync this to Google Cloud so that they can assign the right IAM permissions and give those users and groups the right level of access on Google Cloud. And that is a supported scenario. We have a sync tool that actually syncs users and groups to a domain controller on Google Cloud and allows you to assign IAM permissions. This is great because you actually don't have anything from Google Cloud reaching back into your domain controller on-premise. So it's a nice isolated feature. The two other ways to move Active Directory is an hybrid approach or an all-in approach, as I call it. You can actually have a full trust relationship between a domain controller on-premise and a domain controller in Google Cloud. And you can achieve this via VPN or interconnect. The second option is you actually move your domain controllers to the different zones in a region. And this option is actually better if you want a much higher resilience and lower latencies, because the traffic is all on Google's network and doesn't really have to kind of go over VPN to your on-premise. So different options and different choices based on your needs and scenarios. We cannot do justice to the full thing of the Active Directory, but there was a session at 3:15, and I hope most folks over here attended it. We had a customer, Capital One. I see a few folks who are nodding. So we had a deep dive on each one of these methods, and we also had a customer, Capital One, come and showcase how they actually moved their Active Directory over. So if you missed that session, please look up IO 274 and or come and talk to us, and we'll help you get more information there. Cool. So last but not the least, if you're a .NET developer on a platform, you have a lot of support. So you have cloud tools for Visual Studio. You also have support for .NET Core, both on GKE, which is our Google Kubernetes engine, as well as GAE, which is Google App Engine. We have also added some really cool features in StackDriver, which allow you to debug your .NET code, your .NET production code live. And Simon's going to talk a little bit and show a little bit about that in the next demo. So I'm going to hand it over to Simon to demo how we use some of these tools. So we're going to take a really legacy application and just lift and shift it to the cloud.
All right, thanks, Amruta. So let's talk about this demo a little bit. So we are going to talk about application which is really old legacy application from 2006, .NET Framework 2.0. There is a monolithic web front end talking to multiple databases, and we are going to just lift and shift this application as is into Google Cloud. So let's go into the demo. Okay, so let's first see what our application does. So this is really an old sample of e-commerce shop with the old stack. You can explore categories, you can buy stuff, you can log in. So basically yet another eShop application. So let's go into the Google console and see that essentially, what we need to do is deploy it under a compute engine. So we will have two instances. One of them will run IIS with the front end, and another one will run SQL Server with all those databases. Now, Amruta spoke about the database piece quite a bit, so I'll focus on the IIS piece. So let's go into Visual Studio for a minute, and this is the code of our demo. Everything is available, and you can later on refer to the full example that we are demoing here in the reference slides. So I downloaded Cloud Tools for Visual Studio, and then if I go into the Tools, and then Google Cloud Tools, and Show Cloud Explorer, you can see different artifacts of our cloud, including Google Compute Engine. So if I want to deploy a new instance of IIS up and running, I just do right-click and new ASP.NET instance, and that will open a screen where I just need to hit on this button, and that will make it work. Basically, it will one-click deploy the VM, configure Windows and IIS for me, as well as all the networking settings that we need to set up. I can use this cloud tools for some other stuff as well. It will make me a lot more productive. For example, I can go into firewall options and then decide to open up some more ports. For example, if I want Visual Studio remote debugger or some other things, I can just tweak it here. Everything can be also done through the command line or through the UI, but this is really a very convenient way to do things from within your integrated development environment. So that's our first demo, and over to Amruta.
Great. So this was a really, really simple application, and in a matter of a few minutes, you could actually spin up both the VM as well as the backend and have your application up and running on Google Cloud. So let's kind of talk a little bit more about this journey and how you can modernize it more. So before we go into some of the options available, the question is, why modernize? And talking to customers, they come up with generally 3 pieces of feedback. Folks want to modernize because they want to reduce cost and complexity. If you just lift and shift VMs as is, you're going to save on hardware cost. You're going to run on Google-grade infrastructure, but you still have a monolithic application. You cannot size it or change it up easily. The second one is speed and agility. So as you kind of saw, the pet shop application, you kind of noticed that there were a few different pieces to it. There was an ordering, there was a catalog, there was a product, and there was a web front end. Now, let's say your site becomes really, really popular, right? And the load suddenly spikes, let's say Black Friday, and people just want to buy a lot of goldfish. You don't have the ability to very quickly scale up or scale down your ordering part of that application. So people want to break this up into microservices so they have the ability to turn up and turn down things as the load changes. Third is cross-platform support. As we go into the world of cloud, customers want to make sure that they have the flexibility of running on multiple clouds and in multiple environments. Customers want to be able to run their workloads on their choice of operating system. So these are some of the main concerns as to customers have and some of the motivations they have to actually reconsider how these applications are architected. There are many ways to modernize your applications. You could completely refactor. You could use more managed services. Today, we want to talk about modernizing by moving to containers, because this is one of the most popular areas, and we've got a lot of feedback over here that this is a really great way that customers want to move their workloads and modernize them. So let's see what support we have for them. So today, you can actually, Windows Server 2016 was the first version of Windows that had support for containers, so it had support for the Docker engine. We have support for container-optimized Windows Server images. So just like you have that whole list of Windows images, you can actually take an image, run it on, take a Windows container-optimized image. It has your Docker images already pulled for you with the right networking settings, and you can just deploy a Windows container on it. If you want to go more cross-platform, Microsoft introduced ASP.NET Core or .NET Core technologies, and they've been constantly investing in moving a lot of the libraries from .NET to .NET Core. And this actually gives you the flexibility of running it either on a Windows container or on a Linux container. So if you were to kind of develop on .NET Core and run it on a Linux container, you can actually now move that entire workload on running on GKE or GAE. So GKE is Kubernetes, managed Kubernetes service, and Google App Engine. So if you absolutely don't want to do any management, GAE is your better bet. So a little bit about why you should bring these containers to Google Cloud. Everything at Google runs in a container. All the demos you see, all the different services that we have, they all are container-based. We launch an average of about 4 billion new containers per week. And this has really allowed us to improve the tooling and our systems for managing these containers at scale. We've also been contributing to a pretty successful open source project, which I think a lot of you will be familiar with, Kubernetes. And we're constantly adding more and more improvements to that, as well as it's great to see all the work that the developer community has done to make this project successful. Just like we have support for Linux containers and Kubernetes, there's also an open source project and a working group that's looking at Windows container support, and we're actively involved in that group. So now let's kind of look at how we can take our really, really old pet shop application and modernize that using some of the tools we just spoke about. So I'm handing it over back to Simon.
Thanks, Amruta. So this is just a reminder of the simple architecture of our pet shop application. And now what we want to do is slightly modernize it. So in this case, you can see that we will try to expose some of that functionality as microservices. So we'll still have a front end, which is Windows and IIS, and that will work against 3 microservices: orders, product, and profile. Those, in turn, will work against managed databases. So why doing that? So you get a lot of architectural benefits from doing that, such as auto-scaling, or basically a lot of good scenarios for doing scaling with Google infrastructure, as well as very good and easy integration with Visual Studio and StackDriver Debugger, which I'll show you in a few moments. So let's delve into the demo. So it's the same pet shop application, but this time it will work using a bit different architecture. So I already did some pre-work by exposing the functionality as microservices. If you have ASP.NET MVC services and you want to move them to ASP.NET Core, there is a relatively easy path to do that. If not, you will have to create your ASP.NET Core services from scratch and gradually move your functionality over. So I already did that, and in this case, we'll talk about taking that and basically doing containerization. So I added a Docker file. I'll demo that on one of the microservices, but we need to do it for the 3 of them. So this is the Docker file. You define the image, the base image that you want to use. And in Google, we support multiple ASP.NET Core images for different purposes. So you can base off of one of the images that we support. You define how to run your application, which ports to expose, and some of the environment variables that may be useful for running this properly on the Google Cloud. And then essentially, once we do that, we need to build the container image and push it into a container registry. So let's take a look at some existing container registry images that are already pre-created. So let's go into orders, for example. And you can see here that these are different images that they pushed. I can tag them. And then essentially the whole point is that we can create Kubernetes cluster, which will run our microservices in containers using one of the images that we pushed into container registry. And then we can get a lot of benefits of Kubernetes. So let's take a look at some of that. So what I can do is run a command line Cloud SDK shell. So I'll run a command which will show that we already have a cluster, Kubernetes cluster that I pre-created. I'll show you in a moment how to do that. So this command can show you that we run the microservices in pods. And pod is the minimal deployment unit for Kubernetes. So you scale your microservices in pods, you deploy them into pods, and you can see that for every microservice we have one pod up and running. In order to create Kubernetes cluster, you can just go into this web UI under Kubernetes engine. There is an option to do that by clicking on Create Cluster. There are also other options available, such as command line tools that you can use. So essentially, to create the cluster, you just need to fill up the name of the cluster, the location, the version of Kubernetes that you want to deploy. And then there are certain features that you can make available, such as StackDriver logging and monitoring. And if you open this more thing and then scroll all the way down, you can see that we are pretty secure offering in here because we can basically define what Google services will be available from that Kubernetes cluster. I can do that for all the API. I can do that with full granularity. So in our later sample, we're going to show how we can use Cloud Debugger. So for that, we need to go all the way down and then enable Cloud Debugger feature. And then essentially, we can click on Create, and that will create our Kubernetes cluster. So let's say that we have Kubernetes cluster up and running already. Let's see what we can do with this. So one thing I can do is just run kubectl get deployments. Now, kubectl is the command line tool to manage your Kubernetes clusters, for those who are not familiar. And we are going to use this to talk to our pet shop cluster that I already pre-created. You can see that we have 3 deployments here, 1 and 1, meaning that we wanted 1 copy of each, and we actually get 1 copy of each. But the whole power is what happens when we want to scale. So with Kubernetes, you get these scaling capabilities basically for free, and it makes it very efficient by taking care of all the scalability work for you. So you can do kubectl scale deployment, and let's say we want to scale order service. And I want to have 3 replicas. So what this command does, it basically tells Kubernetes that we want to spin up 2 more instances of our deployment, and Kubernetes will do all the heavy lifting for us. And to kind of check on that, we can just run, again, the kubectl get deployments, and you can see here that now the desired and the current changed to the 3, just like we asked. We can also run kubectl get pods, and see these are the 3 instances that were created. So we basically just run one single command, and Kubernetes was able to scale our ASP.NET Core application really easy. Now let's scale back. So in this case, I just go back to 1 replica, and we can run get pods again. And in this case, you can see that the 2 replicas that we want to kill, they're in the process of being killed, and essentially we'll have 1 instance of every microservice up and running. Okay, so that's all good. We can scale with Kubernetes, and Kubernetes will take care of the scaling capabilities, but there is more to that. So what if we want to handle resiliency of our services? So let's try to kill one of the pods, which will essentially kill our microservice, and see what happens. So first of all, I'll run kubectl get pods again to just kind of confirm the starting state. And now we basically want to kill one of the microservices and see what happens once it runs under Kubernetes cluster. So kubectl delete pod, and I'll just copy the name of that pod. And you can see that it was deleted. Now if I run kubectl get pods, you can see 2 copies of that profile service. So one is terminating and another is running, which is actually very interesting, because what happens here is that the one that is terminating is that copy that we tried to kill. So it takes time until it's actually gets killed. But then Kubernetes was smart enough to recognize that we desired to run 1 instance of profile service. So if your service was affected and essentially failed, Kubernetes will bring another copy of that service back up automatically for you. If you have multiple copies, it will do that with multiple copies as well. So by just moving to Kubernetes with your ASP.NET Core workload, what you're able to get is full handling of resiliency as well as scaling capabilities, which is really, really cool. Now, another thing that we might want to consider is the feature called StackDriver Debugger. Now, this feature currently is in preview, but the fact that we are running in Google Cloud Platform with ASP.NET Core allows us to do the following. So I'll open my debug screen on the Google Cloud Console, And you will see here that this is basically the screen where we can production debug our application. Now, it sounds like a bold statement, but this is actually what it is. What this application allows us to do is opening the source code of our application, attaching the breakpoint to existing running application in production, and then inspecting the snapshot that StackDriver will take from our application if we hit that particular code path which leads to the breakpoint. So let's try and see how we can do that. So in this case, I can bring my source code from multiple locations. We have integration with GitHub, GitLab, Bitbucket, cloud source repositories of Google Cloud, as well as you can also bring your own sources. So this is what I will do. I'll take my local sources, and I'll hit upload. Now, this is not really uploading into cloud. This is just opening that locally on my browser. And you can see this is the code of the application. We'll try to debug service called products. And if we explore some of its code, there is this category controller. And we can just go explore what it does. But one of the actions here called category, and we can see that it tries to use caching. So if caching is enabled, we might use it. Otherwise, we will not use it. So let's inspect whether caching is actually enabled. So that is kind of modeling the real-world scenario where you have something running in production. Something happened. You want to understand what is the state of your application without redeploying with additional instrumentation that you might want to add. So you can just add your breakpoint at the place where you want to stop. And now it's waiting to hit that code path. Now, how do we know how to get into this method? So in Kubernetes, I did some pre-work, which was exposing all my microservices with external AP. So I created a load balancer object, and I exposed my microservices externally. So I'll run kubectl get services. And this will return all of my services running under Kubernetes with their external AP. We are talking about the product service, so I'll just copy this external AP from here. And if you look at the source code, there is this route called category. So in order to reach this code path, what we need to do is go into this IP and then /category. So let's do that. So this opens some information, which is categories of our pet shop. And let's go back into debugger. So you can see here that suddenly it shows all the call stack of that code path. So basically, we hit the breakpoint. There is the call stack of what really happened up until that point. Okay, this is the real application. And also, we are able to see here all the variables that and their state at that moment when this snapshot was taken. So I can open up this state and then take a look at this caching enabled variable. You can see it's 0, which means false. This kind of gives me the idea of what's going on with my application. Now, all those snapshots are really a powerful feature, and there is almost no overhead to run that. So you can run that in production safely. You can be sure that it will not run on all of your CPU or memory. The overhead is almost next to nothing. And it gives you this powerful capability of exploring your application state if you really need that. And then there is also this snapshot history. So you can share this state with other developers by just sending them link into the relevant snapshot and essentially get to know what's going on with your application. All right, so let's switch back.
Cool. So hopefully we've demonstrated to you how easy it was to just lift and shift, and Simon just demonstrated to you some of the amazing capabilities that just light up if you were to refactor and move this to microservices on GKE. A lot of the work it was sort of done and sort of explained quickly because we have a short time, but we have a detailed set of white papers that we wrote with one of our Windows partners, Magenic, and they go into an extremely detailed explanation for the same application of how you could move and the different pieces and the tools. And all the work done is actually available. The code's available, so you're free to kind of look at some of the examples and see how we did some of the migration there. In addition to that, we'd like to also leave you with some of the links. So if you go to like cloud.google.com/windows or SQL Server, we have a lot more information and white papers and best practices. And we also have similarly information about our developer tools. So we will probably be sharing these slides after the sessions. So these are really good links to kind of go and get more information.